Hello students, welcome to Chemistry by Praveen Kumar Patidar. In today's video, I am going to discuss about decomposition reactions. In my previous video, I discussed about one category of decomposition reaction, that was thermal decomposition reaction. So decomposition reaction in which a single reactant convert into two or more products. If the reaction carried out using heat, then it is thermal decomposition reaction. And if we are carrying out the reaction by passing electrical energy, that is by passing current, it is called as electrolytic decomposition reaction. And the best example of electrolytic decomposition reaction is electrolysis of water. So I have taken this activity. In this activity, we have taken water in a container that is fixed with two graphite electrodes. One work as cathode, another work as anode, and that is connected to 6-volt battery source and plug key. We have kept two inverted test tubes to collect the gases formed during the reaction. And see, in this reaction, we add small amount of sulfuric acid. Many times this question is asked, why dilute sulfuric acid is added during the electrolysis of water. So this small amount of H2SO4 is used to increase the speed of reaction. Okay. So H2SO4, it increases the speed of reaction. We are using small amount of 2, 4, 5 drops of H2SO4 in this process. When we switch on the plug key, our reaction starts and this H2O decomposes to give H2 and O2. Hydrogen gas is obtained at cathode and oxygen gas is formed at anode. And if you see in this particular diagram also, the volume of hydrogen collected, it is nearly double of the volume of oxygen collected. Why it is happening? So very simple, that is, in the balanced chemical equation, ratio of hydrogen to oxygen is 2:1. That's why the volume collected, hydrogen and oxygen, it is 2:1. Right? Hydrogen, it is at cathode, oxygen, it is at anode. Now suppose I am making diagram and I am not labeling any electrode or other things, and one asks that where the hydrogen collected, you can easily label. Where the volume is more, that is hydrogen, and volume is less, is oxygen. This electrolytic decomposition used in many other processes. I have taken two more reaction when molten sodium chloride is electrolyzed. It gives sodium and chlorine gas. And see, commercially sodium metal is obtained by this process only. It is called Downs process. Right? When we electrolyze molten alumina, it gives aluminium and oxygen. Again, aluminium at cathode and oxygen at anode is formed. And aluminium metal is also extracted by this process only. So we can understand one another thing, that electrolytic decomposition is used in extraction of metals also. So this is what about your electrolytic decomposition reaction. Okay. So third category of decomposition reaction is photolytic decomposition reactions. As I told you, these photolytic decomposition reactions carried out in presence of sunlight. And we have best example, say silver salts. Right, I have taken here two silver salts, silver chloride and silver bromide. But whenever I am talking about the silver salts, these silver salts are photosensitive. Right. So you observe that whatever silver compounds we are using in the laboratory, say silver nitrate, one very commonly used compound, they are always stored in dark colored glass bottles and they are kept in dark. Why? So that sunlight cannot affect that particular substance. Okay, so I have taken two examples. Silver chloride, in presence of sunlight it gives silver and chlorine, and silver bromide, in presence of sunlight, gives silver and bromine. And we can show it with the help of an activity. We can take small amount of silver chloride in a watch glass, okay, and we should keep it in sunlight for some time, 15 to 20 minutes. And after 15 to 20 minutes, this silver chloride, it is white in color. Okay, silver chloride is white in color. And after 15 to 20 minutes, it turns to grey. Means what happens? Silver chloride decomposes to give silver and chlorine. So this is example of a photolytic decomposition reaction. And particularly this reaction AgBr, it is used in black and white photography. This reaction is used in black and white photography. Now next category of reactions we are taking are displacement reaction. As from the word displacement, it is very clear that one substance is going to displace some other substance. So what is a displacement reaction? A more reactive element displaces a less reactive element from its solution. Okay. So I have taken one example. If we take copper sulfate, it is blue in color in a test tube. It's copper sulfate. And when we add iron nails or some other iron object in this solution, after some time what we find that there will be a brown colored deposition of the copper at the bottom, and your blue solution turns to light green. Means what happens? Iron is more reactive than copper. It has displaced iron from copper. It has displaced copper from copper sulfate solution and forms FeSO4. So a more reactive element displaces a less reactive element from the solution is called the displacement reaction. See another example I have taken. If I take zinc with FeSO4, we get Fe plus ZnSO4. Similarly, if I take silver nitrate solution AgNO3, and if I add small amount this copper turnings, what happens? The solution turns to blue, that is copper displaces silver from silver nitrate. Similarly, if I place few particles of zinc in dilute H2SO4 solution, there will be liberation of hydrogen gas, and see zinc will displace hydrogen from H2SO4. But if I take copper plus H2SO4, copper will not be capable to displace hydrogen from sulfuric acid. It means we can say copper is less reactive than hydrogen. From these all we can conclude few concepts. Only from this concept. Zinc is more reactive than iron. Iron is more reactive than hydrogen. Hydrogen is more reactive than copper. Copper is more reactive than silver. Means if I place iron in zinc sulfate, there will be no reaction. Why? Because iron is less reactive than zinc. That's why iron will not be capable to displace zinc from zinc sulfate. Okay. Similarly, if I take copper sulfate and silver, so what happens? Copper will not be capable to displace the silver, right? And reaction will not occur. And when these elements, particularly metals, are arranged in their decreasing order of reactivity, a series is formed that is called reactivity series. And that reactivity series, I have taken just example here, we'll be studying chapter metals and non-metals. Now from this we can conclude one another thing. If someone asks, can you store copper sulfate in a container of zinc? What should be your answer? Yes or no? So we can't store. Why? Because zinc will displace copper from copper sulfate solution. And what happens? Your vessel will get corroded and there will be leakage of copper sulfate solution. But reverse, we can store zinc sulfate in copper vessel. So this type of concepts can be explained using your displacement reactions. Right? Clear? Now we have fourth category of reactions, double displacement reactions. And when we are talking about double displacement reactions, means we have 2 times displacement. 2 times displacement means there will be a mutual exchange of ions. Means double displacement reactions are those in which mutual exchange of ions takes place. Generally, these double displacement reactions accompanied with formation of precipitation. Generally, that's why these reactions are also called as precipitation reactions. I have taken few examples. Say if I take silver nitrate aqueous and sodium chloride aqueous in 2 separate test tubes, and if I mix them, what happens? There will be mutual exchange of Na plus and Ag plus ions. We will be getting AgCl and NaNO3, and this AgCl, it do not dissolve in the solution, it forms white colored precipitate solid. And precipitate generally we show by downward arrow. Whenever there is downward arrow, that shows formation of precipitate. Similarly, if I take barium chloride, again it is colorless, and I add sodium sulfate to this, or any other sulfate, not necessarily this sodium sulfate, you can take any other sulfate soluble in water. It forms white precipitate of BaSO4 and it will give you NaCl. If I take aqueous lead nitrate and add aqueous potassium chromate to this, what happens? There will be formation of yellow PPT of lead chromate, PbCrO4 plus KNO3. Okay. Similarly, if I take lead nitrate and potassium iodide, there will be formation of yellow PPT of potassium, this lead iodide, PbI2 and KNO3. So these are few examples of double displacement reactions. Total we have 4 category of reactions: combination, decomposition, displacement and double displacement reactions. Okay, so this is all about your 4 basic kinds of reactions. You can practice this from your textbook as well as from the exercise questions, right? Thank you.